Hello, today's video is going to cover introduction to sequences. So this unit is going to be over sequences and series. And a sequence is literally just a list of numbers, and a series is when you add those numbers together. So the sequence has a pattern. We're going to actually write a definition to that. So I apologize in advance that this lesson is a lot of definitions. So go ahead and take a minute, pause the video, and write these down. A sequence is a set of numbers with a particular order or pattern. Each number is called a term. A finite sequence is a sequence with a limited number of terms. For example, 1, 2, 3, 4. That is a list of numbers in a pattern that has a limit. So it's just 5 terms, and they're all right there. And also, this is the proper way to write a series, or a sequence, I'm sorry. Then an infinite sequence is a sequence with unlimited terms. And all we did to signify that is we added this ... so that we could see that this pattern continues and the sequence goes on forever. So now we want to talk about term notation, and this is just how we identify one term from the next. So the first term in a sequence is always denoted as A sub 1. So that's a little 1. And then each term after that, each subsequent term, is denoted as A sub n, where n is the term number in the sequence. So let's look at this example. It gives us a sequence here. We want to identify the following term values. The first one is A sub 1. What that means is this 1 down here tells us that we want the first term in the sequence. So that is just 1. That's not always the case that it's like that. So now we want to look at A sub 4. That means we want the fourth term in the sequence. So 1, 2, 3, 4. The answer to that one is 13. Now we want the ninth value, the ninth term in the sequence. That's what this A sub 9 means. Well, we only have 5 terms. So now we're going to have to find the pattern, and we are going to have to find at least 9 terms. So if we go from 1 to 5 to 9 to 13 to 17, you should notice that we are adding 4 every time. So what I'm going to do is I'm going to keep adding 4. So 17 plus 4 is 21. If we add 4 more, we get 25. Then 29, then 33. So we now have 9 terms. This is our 9th term. So we can answer that A sub 9 equals 33. Or the 9th term is 33. Now we want A sub 12, so we need to take our pattern a little further. So we're going to just keep adding 4 until we get to 12, and 45 is our 12th term. Since each term value is paired with exactly one term number, a sequence is a function with the following properties. The domain is the set of term numbers. So all that's saying is that these are the independent variables. So those are our inputs. And then the range is the set of term values. And in an infinite set, the domain is the set of natural numbers. Now, as a reminder, those are the numbers that you would naturally teach a toddler to say. So this is 1, 2, 3, 4, 5, etc. Counting numbers. So anytime you have to come up with the n value up here, like which term, you're always going to have the first term, the second term, third term, fourth term. So that's what your n values will be. All right, so we are almost to actually getting to do some math, but we've got one more definition before we get there. A recursive formula is a rule in which one or more previous terms are used to generate the next term. So an example of that is the Fibonacci sequence. And a Fibonacci sequence always starts with 0 and 1. But then the next number is the last two numbers added together. So 0 plus 1 is 1. Now our next number would be 1 plus 1. That's 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. Then we'll have 13, 21, 34, etc. This is the Fibonacci sequence. And in this sequence, A1, so the first term, is equal to 0. A2 is equal to 1. Then for each subsequent term, so the terms after that, A sub n is equal to A sub n minus 1 plus A sub n minus 2. Now, this looks a little confusing, but let's think about this. So if we're looking for this term, we're going to add the term that was 1 before it to the term that was 2 before it. So if we're looking for this term, we want to add the term 1 before it and the term 2 before it. So 5 plus 8 is 13. So let's go ahead and actually dive into some math, finally. Number 1, find the first 5 terms of each sequence. So it tells us, so the first thing that we want to do is make our little brackets. And it tells us that the first term, A sub 1, is 14. Now, we want to find A sub 2. So we're going to plug 2 in for n. So if we have A sub 2, and that's going to equal A sub 2 minus 1 plus 9. Well, 2 minus 1 is 1. So we have we're going to have A sub 1 plus 9. Well, A sub 1 is equal to 14. So 14 plus 9 is 23, and that's our next term. Now, the easiest way to think of this is to just think, if we're subtracting 1, that means that this is the term that came 1 before that in the list. So this is just the previous term plus 9. So 23 plus 9 is 32. 32 plus 9 is 41. 41 plus 9 is 50. And then the sequence goes on forever because it doesn't say that it ends. And then that is your answer. This is the first 5 terms of the sequence. And numbers 2 through 4 are just like that. So if we skip down to number 5, it says to write a rule for each sequence, then give the next 3 terms. So we want to, in the last ones, we were given a rule and we found the terms, or we found the terms in the sequence. Well, now it's giving us the sequence and telling us to write the rule. So our answer should look like the problems looked for numbers 1 through 4. So the first thing that those problems told us is what A sub 1 was. So we have A sub 1. That just means the first term. Well, the first term is 4. Easy enough. But then we have to come up with A sub n. We have to figure out what happens to these numbers to get it to equal the next one. So if we want to go from 4 to 11, we could add 7. But then if we add 7 here, that does not get us where we need to go. Okay, so what if we multiply? Let's see. If we multiply 4 times something to get 11, That's not even really a good option. So that's not going to work. There's no easy multiple of 4 to get to 11. Then let's think about combining the two. So how close can we get to 11 without, or from 4? Okay, sorry. Using multiplication, how can we get close to 11 using the number 4? And we can do it by saying 4 times 3. So that gets us to 12. And then if we subtract 1, that'll get us to 11. So let's just pretend that that is our formula. We know that we want to use a sub n minus 1 because we want to use the term that came before the term we're looking for. And we decided that we could multiply that by 3 and then subtract 1, maybe. So let's see if it works with a different term. So if we want to find the third term, that means we would do 3 times the one before it, so 11, and then subtract 1. This would be 33 minus 1, and that does equal 32, which is our third term. So it works there. Let's test it for one more term just to make sure before we assume that we're right. So let's try to see if the fifth term works. So this would be 3 times the term before, so 95, and then we would subtract 1. And this is going to give us 285 minus 1, which does equal 284. So this is our formula. We did it. The only thing you need to add is that this is for n greater than or equal to 2. And we only say that because we already have where n equals 1. We've given them that. So it only matters when n is greater than or equal to 2. When it's equal to 1, it's just 4. So that was an example of a recursive formula, which is what we've been working with. But now we want to talk about explicit formulas. An explicit formula is a rule in which the nth term is defined as a function of n. Previous terms are unnecessary. So this means it completely just depends on the number n. So if you tell me which term you want to know and you give me the formula, I can tell you. I don't have to know any other terms. So let's do number 7 together. This is, remember, an explicit formula because there's an n in it instead of an a sub n minus 1. So our n values, remember we said that if you have an infinite set, then domain is the set of natural numbers. That means counting numbers. So the first n is always going to be 1. So let's make our list or our sequence. And I just kind of like to note up here that this term is for n equals 1. So if I plug a 1 in for n, 1 minus 3 is negative 2, and negative 2 times 7 is negative 14. So my first term is negative 14. Then I want to plug in n equals 2. So if I plug a 2 in for n, 2 minus 3 is negative 1. Negative 1 times 7 is negative 7. Then I want to plug in n equals 3. 3 minus 3 is 0. 0 times 7 is 0. Then I want to continue and I want to plug in n equals 4. And then n equals 5. So if I put in 4, 4 minus 3 is 1. 1 times 7 is 7. Plug in 5. 5 minus 3 is 2. 2 times 7 is positive 14. And this is not limited. It doesn't say that it ends. That's just the first 5 terms. So this is your answer. So now I want us to try and write an explicit formula. So whenever we do this, remember that our formula is going to depend on the value of n. So let's make a list of these numbers in reference to their n value. So n is which term it is, like which number term. So the first term is -7. The second term is -9. The third term is -11. The fourth term is -13. And the fifth term is -15. So we want to figure out a formula to get from here to here. The first thing that I would try to do is notice the pattern here. And if you look, each time we're subtracting 2. So my first thought in our function is to try using multiples of -2 to get us somewhere. So let's just start with -2n and see where we get with that. So 1 times -2 would be -2. So we're trying to get 1 to equal -7. So we've got -2. To get from -2 to -7, we'd have to subtract 5. So let's see if subtracting 5 from that works for all of our n values. So let's pull out n equals 3. This would be -2 times 3 minus 5. So we would get -6 minus 5, which equals -11. So it works for that one. Let's try one more just to make sure. -2 times 5 minus 5 equals -10 minus 5, which is -15. So that works. So this is our formula. Now, it's important that you know that for numbers 14 through 16, you may struggle to find the formula. I don't want you to spend hours on this. This is something I want you to have seen, but you do not have to be perfect at it. The rest of the problems you should be able to do. But numbers 14 through 16, I feel like I don't want to waste your time guessing and checking those all the time. So I would like for you to try at least 2 formulas. So show me that you tried to come up with something and test at least 2 different formulas. And then if you haven't figured it out, then move on. I don't want you to spend hours on this. If you are a perfectionist and just need to solve the puzzle, then go ahead. But these are going to be difficult, so I don't want you to waste a ton of time on them. That is all I have for you. Thank you. Have a great day.